Today we're going to be working with Pythagorean theorem and its converse. And we've seen Pythagorean theorem before, so today we're just going to review it, and then we're going to talk about actually proving that these triangles are right triangles based on their side measures. So the Pythagorean theorem is really a conditional statement that says if the figure is a right triangle, then a squared plus b squared is equal to c squared. And we have these conditions for A, B, and C. So A and B are going to be our legs. And it's not going to matter which leg we use for A or which leg we use for B. We can interchange those if we like to. But it does matter which one we use as C. C is always going to be our hypotenuse. And our hypotenuse is always going to be the longest side numerically. And it's always going to be the side that's across from the right angle. So the first thing we want to do is label our triangle. So here we have a right triangle, and it's given to us that we do have a right angle. That's the little blue square. That means we've got 90 degrees. So I always like to label my hypotenuse first because it's easy to find. It's going to be right across from that right angle. So we can label that C, our hypotenuse, our longest side. Then the other two we can name A and we can name B. Once we're okay with labeling these triangles and labeling our hypotenuse and our legs, we can then start to find actual missing sides of the triangles using Pythagorean theorem. So the first thing we want to do is always label this triangle. We want to label the hypotenuse first, and it's always across from that right angle. So in this triangle, x is going to be our hypotenuse and what we're looking for. And then we can label the remaining legs A and B. And if I wanted to here, I could label the 4 as A and the 10 as B, as long as we know for sure that those are not the hypotenuse. Then we're going to substitute our values into the Pythagorean theorem, and we are going to solve for the missing variable. So our Pythagorean theorem is A squared plus B squared is equal to C squared. I plug in. So A is 10, so I say 10 squared plus B squared, which would be 4, so 4 squared is equal to x squared. And we want to make sure we always use parentheses, especially for plugging into the calculator, because we want to make sure that we are squaring that entire value. So I get 100 plus 16, and that is equal to x squared. So next I'm going to combine my like terms. So 116 are on the same side of the equal sign, so I can just add those. Remember, if we're on the opposite side, we need to use that inverse operation. And in order to get x by itself, we're going to have to take the square root of both sides. So I take the square root of x squared, I take the square root of 116, and we're left with the square root of 116 is equal to x, or x is approximately 10.77. So we said at the beginning that the Pythagorean theorem is an actual conditional statement. If the figure is a right triangle, then a squared plus b squared is equal to c squared. So with our converse, we go back to our vocabulary for that, and we know that our hypothesis and our conclusion are going to switch. So in the original theorem, if the figure is a right triangle, that's our hypothesis, so it's going to now become our conclusion. And our original conclusion, then a squared plus b squared is equal to c squared, that is going to become our new hypothesis. So the converse is going to say, if a squared plus b squared is equal to c squared, then the figure is a right triangle. So let's look at this triangle. Is this triangle a right triangle? We can use our Pythagorean theorem converse for this. So the first thing we want to do is we want to label the largest side numerically. So the largest numbered side, not necessarily the largest side visually, because it's not always going to be drawn to scale. So 10 is the largest number out of 6, 8, and 10, so we'll label that C. And we can label the remaining legs A and B. And remember, 6 and 8 can be interchanged here if you would like to. Then we're going to plug all 3 of these values into the Pythagorean theorem. If we solve each side of the formula, they will tell us whether or not this triangle is a right triangle by the equivalency. If each side is equal to each other, it is a right triangle. If each side is not equal to each other, then it is not a right triangle. So a squared plus b squared is equal to c squared. We're going to plug that in. So 8 is a, 6 is b, and 10 is c. So we plug those in and we do our squaring, so 64 plus 36. And on the other side, we have 10 squared, which is 100. We can do our addition, 64 and 36, and we get 100 is equal to 100. So this is a right triangle. Now this triangle, we have 3, 7, and 12. So we want to do the same thing again. We want to label our largest number. So that's going to be 12. That will be our hypotenuse if this is a right triangle. And A and B, we can label 3 and 7. And if you wanted to, you could label 7 as A and 3 as B. Then we're going to substitute into the Pythagorean theorem again and see if both sides of our equation are equal to each other. So a squared plus b squared is equal to c squared. We have a, which is equal to 3, and 7, which is equal to b. And then we have 12, which is our c value. So 3 squared plus 7 squared is equal to 12 squared. If I square 3, I get 9. If I square 7, I get 49. And if I square 12, I get 144. So then we can combine the 9 and 49 on the left-hand side of our equation to get 58 is equal to 144. And that's not a true statement, so this is not going to be a right triangle.